Chapter 12 Electricity. Some more numericals I'll teach you through this video. Page number 219. Example 12.5. Resistance of a metal wire length 1 meter is 26 ohm. This symbol is called ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Using table 12.2. In page number 218, one table is available. Predict the material of the wire. Now resistance of the wire R is 26 ohm, diameter D 0.3 mm, radius R is equal to 0.3 by 2 millimeter. Now convert into meter by dividing 1000. So 0.3 by 2 into 1000 meter. Remove this decimal, so 3 by 2 into 10 into 1000 meter. 3 by 2 gives us 1.5, and this is 10 to the power 4 because 1 with 4 zeros are there. If it is going up, it will be 10 to the power minus 4 meter. Now length of the wire L is 1 meter. Now resistivity of the metal, this symbol is called rho. Rho is equal to R into A by L. This formula also given to you. You should note down properly. So rho is equal to rho for resistivity RA by L. R into A is area of the cross section, that is pi r square, downside L. R is 26, pi you can take 3.14, radius 1.5 into 10 to the power minus 4, 2 times you can write, divided by length is 1, ohm meter is the unit. This 10 to the power minus 4, 10 to the power minus 4 you can combine. Same base sign into power plus, so 10 to the power minus 8 will come. And 26, 3.14, 1.5, 1.5, all this should be multiplied together. Then you will be getting 183.69 into 10 to the power minus 8 ohm meter. In scientific notation, decimal should be after one number, not after three numbers. That's why point should be taken after 1. Bring 2 digit back. So 1.8369. Since point you are bringing 2 digit back, into 10 to the power 2 you must multiply, into 10 to the power minus 8 ohm meter. This becomes 1.84 because your third digit is more than 5. That's why you are converting after decimal 2 digit only, 1.84 into same base sign into power plus. So 2 minus 8 makes 2 minus 8 makes minus 6. So 1.84 10 to the power minus 6 ohm meter. Now from the table 12.2, if you will observe this resistivity, that resistivity is given for manganese. Therefore, resistivity of the metal at 20 degrees Celsius is 1.84 into 10 to the power minus 6 ohm meter. So from the table 12.2, we can see that this is the resistivity for manganese. So answer will be manganese. Material name is manganese. Now page number 220, example 12.6. A wire of given material having length L, area of cross section A, has a resistance 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of the cross section 2A? So for the first wire, resistance you can mark by R1, which is given 4 ohm. Now R formula, rho into L by A. As per resistivity, your formula is rho into L by A equals to 4 ohm. Number 1. For the second wire, R2 is equal to rho into L. Here L is given L by 2 and cross section area is given 2A. So rho into L by 2 by 2A according to formula. Actual formula rho into L by A, but here L is L by 2 and A is 2A. Then rho into L by 2 to the 4A. 1 by 4 we are keeping separately into rho L by A. Now rho L by A value is 4 ohm. So here you can put 4 ohm. Then 4 cancel out. It is coming out 1 ohm. So resistance of the new wire is 1 ohm. Next example 12.7, page number 223. An electric lamp whose resistance is given 20 ohm and a conductor resistance is given 4 ohm are connected to a 6 volt battery in this figure. So 4 ohm, that is conducting wire, and this is your lamp resistance 20 ohm, connected side by side, that is in series connection. This is the battery, 6 volt battery is attached. This is ammeter, this is key. Current is flowing in this direction from positive to negative. Now first question they are telling us to find total resistance of the circuit. Second question, current through the circuit. And third question, potential difference across this lamp also, across this conductor also. So first you write resistance of the lamp R1, that is 20 ohm. Resistance of the conductor R2, 4 ohm. Now first answer. As the resistances R1 and R2 both are connected in series, then the total resistance of the circuit RS is given by, for series connection, your formula RS is equal to R1 plus R2. Even many are there also, just by adding we can get the total resistance RS. So RS is equal to R1 plus R2, formula already given to you through the audio. Even in the textbook also formula is available. So 20 plus 4, it becomes 24 ohm. So total resistance in the circuit 24 ohm, because it is connected in series connection. Now second question, I have to calculate current, and third, potential difference across the lamp also, across the conductor also. Now question number B. Total potential difference across the two terminals of the battery, that is V is equal to 6 volt, it is given. Now as per Ohm's law, I is equal to V by R, but here R is RS. Now V is 6 volt, RS, that is total resistance 24 ohm. After cancellation, it is coming 1 by 4 ampere, that is 0.25 ampere. Therefore current through the circuit is 0.25 ampere. Number C, potential difference across the electric lamp, that is V1, we are saying I R1 is the formula according to Ohm law. So I is 0.25 ampere and R1 is 20 ohm. After multiplication, it becomes 5 volt. And potential difference across the conductor, that is V2 is equal to IR2, that is 0.25 ampere into 4 ohm. After multiplication, it is 1 volt. So potential difference across the lamp is 5 volt and across the conductor is 1 volt. 5 plus 1 together gives us 6 volt, and battery power also given 6 volt. With this answer is completed. Now page number 224. One question is given. Draw a schematic diagram of circuit consisting of a battery of 3 cells of 2 volt each and a 5 ohm resistor, 8 ohm resistor, 12 ohm resistor and a plug key, all connected in series. So first, the potential difference of each cell given 2 volt. Then total potential difference will be for 3 cell, 3 into 2, 6 volt. So the following circuit diagram which we are drawing shows 3 resistors of resistances 5 ohm, 8 ohm, 12 ohm are connected in series, and a battery of potential difference 6 volt, plug key which is closed, means the current is flowing in the circuit. Now this is your circuit diagram. You have to draw with the help of scale pencil in a proper way. This is your plug key, this is your battery, this is your current is flowing, conducting wire, 3 resistances or resistors, it is fitted in series connection, etc. Now question number 2, they told us to redraw this circuit of question number 1 and putting in ammeter to measure the current through the resistor and 1 voltmeter to put to measure the potential difference across only 12 ohm resistor. What would be the reading in ammeter and voltmeter? Now this diagram will modify in question number 2. Modify means slight change will be there. This is the diagram for question number 2. Ohm, resistor, all are same only little modification. Here we are fitting ammeter to measure the current. Then R1, R2, R3 you can say. This potential difference I have to calculate. Battery 6 volt, this is plug key. Diagram should be drawn perfectly. So here R1, R2, R3 should be selected. As the resistances R1, R2, R3 are connected in series, then total resistance RS is given by RS is equal to R1 plus R2 plus R3. Total is coming 25 ohm. Now potential difference V is given 6 volt. So according to Ohm law, I is equal to V by R. So V by RS you can write. That is 6 volt by 25 ohm. After division, it is coming 0.24 ampere. Therefore, ammeter will show a reading of 0.24 ampere. First answer over. Now they are telling us to calculate the potential difference across 12 ohm resistor, that is I into R3. R3 because of only for 12 ohm they are telling us to calculate the potential difference. That is voltage for this portion only. That's why formula will be IR3. I is 0.24 ampere into 12 ohm. After multiplication, it is coming 2.88 volt. Therefore, voltmeter will show a reading of 2.88 volt. With this, I'll conclude today.